of motion, we were discussing about momentum. So we have discussed this momentum, which was represented by the symbol P, is given by the formula m into v. Okay. So momentum is a vector quantity and it is equal to mass into velocity. It is the product of mass and velocity. The direction of momentum is the direction of velocity. The direction in which the object is going, that is the direction of velocity. Then we had discussed in the second law of motion. So in the second law, we had discussed that force is directly proportional, or force is equal to the rate of change of momentum, which we wrote here, mv minus mu divided over t. So rate of change of momentum is equal to the force. And we had seen a few questions from like football player kicking a football player kicking a football, okay, and similar other things we had seen over here. Okay. So understood this, the second law of motion. Okay. Now the second law of motion, it is the real law of motion. So from here, if you take out mass as common, if you take out mass common, so you have mass times v minus u over t. Okay. So v minus u over t is your acceleration, and hence you can write it as mass times acceleration. Okay, so that is why you also have the formula force is equal to mass times acceleration. Okay. So this force which we are talking is the external or external unbalanced force, or the net force acting on an object is equal to the mass times acceleration. Okay. So you will get very small numericals in, let us try to find out small numericals that we can get and try to solve those questions. Okay. So first one is, what force is required to accelerate a motorbike of mass 250 kilogram by 2 meter per second square. Okay. So who can do that? 2 meter per second square. What force is required to accelerate a motorbike of mass 250 kilogram? So clearly, we see here that the
Sir,
acceleration. Yes.
is it 500 kg meter squared?
Okay. So you get here a force will be given by the formula. Force will be equal. Okay. You can say 500 Newton, right? As it is equals to mass times acceleration. So if you multiply it, you have the force of 500. Okay. Then,
Sir, would it be right if you said 500 kg meter squared?
yeah, it would be the same. It would be the same thing. It would be correct. Okay. Then, second part over here, I have the second part also. So you have how much force will be required if a 200 Newton force if friction force of 200 Newton acts on the bike, so how much force will be required to have same acceleration if friction force of 200 Newton acts on the bike. So we have the frictional force 200 Newton, and now we want to find out that how much of the force is required. What will be the total force required? So to accelerate the mass again through the same acceleration, so that the mass again has the same acceleration of 2 meter per second square, the net force on the bike should be equal to 500 Newton. Yeah. If the net force will be equal to 500 Newton, then only you can say that the acceleration will be 2 meter per second square. Right, Rishika?
Yes.
So we get here net force. If I want to find out the net force, I find it as net force will be equal to applied force minus the force of friction. Since friction always opposes motion, so friction will be subtracted by this.
So it will be 300.
No, just see, do not be in a hurry. The formula is correct. You have the net force should be equal to applied force minus the force of friction. Now, so the question asks you how much force is required to have the same acceleration. So the acceleration should be the same. That means the net force should be 500. Okay. So here your net force should be 500 and it should be equal to the applied force which we want to find out. Here we want to find out the applied force. So applied force and minus 200. So that's the friction. So can you tell what will be the value of the applied force then?
700.
700 Newton. The bike has to apply a force of 700 Newton to pull it with a force of 500. Okay, let's see another question. Yeah. So a boy tries to pull a cart of mass 300 kilogram 300 kilogram with a force of with a force of 500 Newton. So you have to tell what will be the acceleration. What will be the acceleration of the cart if there is a friction of 100 Newton. Okay. So if there is a friction of 100 Newton on the cart, so what will be the acceleration? So, Prince, what will be the net force acting on the cart?
Sir, applied a net force
Yeah, what will
500 Newton.
see? He's applying a force of 500 Newton. Okay, and there is 100 Newton of force of friction. So, what should be the net force acting on the cart?
Sir, 400.
400 Newton, right? So, I'll get here my net force. So, I can write here my net force will be equal to 500 Newton minus 100 Newton, which will be equal to 400. Okay, so net force is 400 Newton. We know the mass, so we can find out the acceleration.
Sir, I got 4 by 3 meter per second square.
Yeah, so acceleration would be equals to 400 over 300, and that's 4 by 3 meter per second square. Ora Smith and Harini, you also turn on your cameras. So everyone can understand up to finding out the acceleration.
Yes, sir.
Okay. Now, the next one is your third law of motion, and after that we have the conservation of momentum. Okay. So let's see the third law of motion. As per the third law of motion, what does the third law of motion state?
Sir, every action has a equal and
opposite
reaction.
reaction.
Yeah, for every action.
There is an equal and opposite reaction.
Yeah, for every action, there is an equal and opposite reaction. So if I can say that the two forces are equal and opposite.
Yes.
Yes,
So
sir.
if the two forces are equal and opposite, so why don't they cancel each other? A very common question. That if the action and reaction forces, they are equal and opposite to each other, so why don't they cancel each other? Why we will have motion then? They should always cancel each other. As per the third law, for every action there will be an equal and opposite reaction. So that means you are supposed to have a reaction for every action. So how will the motion be possible? How will there be a net force? I'm going to get my net force to be equal to 0. So how will the motion be possible? Or how is the motion possible? Okay. A very simple answer to this question is that action and reaction, they act on two different objects. So action and reaction act on two different objects. So the action force and the reaction force, they act on two different objects. So that is why you have the third law of motion, that is action is equal and opposite to the reaction. Got it? Understood this?
Yes, sir.
So let us try. I think you have not. Let us try to imagine the situation, what we are trying to see here, what we are trying to say here. So you have first two objects. Let's say you have these two objects, object A, and you have an object B. Okay. So these are two objects. You have your object A and object B. So let us say the object A applies some force on B. Okay. So object A tries to push this object B. Okay. So as per the reaction, the object B will also push the object A.
Yes, sir.
So object B will push the object A. We see here that the two forces, action and reaction, They are equal and opposite, but they are acting on two different objects. Okay. The force on B is in the positive direction, but the force on A is in the negative direction. Okay, so the two forces, they are acting on two different objects. That is why they cannot cancel each other. So this is what we have in the third law of motion. We will try to understand this with some other examples also. Let us try to get this. Suppose if you have a spring balance or a spring. So you have a spring, and with this spring you are trying to pull another spring. So here you have another spring. Okay, so here you have another spring. Now if I say that both the springs, they are same. They are identical in all the respect. So if this spring has produced an extension of, let's say, 2 centimeter, so what will be the extension produced by the second spring? Yes, what will be the extension produced by the second spring then?
Two centimeter.
2 centimeter. As the action and reaction forces, they are equal. So if the first spring is pulled by 2 centimeter, so second spring will also be pulled by 2 centimeter only. Okay. So this is your action and reaction. Now let us see another important concept, that is conservation of momentum, which is based on action and reaction forces. So conservation of momentum, it states that the total momentum of a system remains conserved if no external force acts on it. Act on it. Okay. So this is your conservation of momentum, that is the total momentum of a system, it remains conserved. System means a system may be made up of one particle, two particles, or three particles. So of whatever number of particles a system is made up of, its total momentum remains conserved. So for example, a very simple, if we take here two objects, so if we have two objects moving with some velocities, let us say you have the object 1 and here you have the object 2. So if you have two objects, okay, see, you have two objects, let this be object 1, 2, you have 1, 2 and again 1, 2, right? So let the first object have mass m1, second object have the mass m2. This again, the masses have your m1 and m2. Again, they have their masses as m1 and m2. Masses do not change. Okay. So suppose the mass m1 was moving with some velocity u1, mass m2 was moving with some velocity u2. Here they collide with each other. So after collision, they move with some different velocities. Let us say m2 moves with velocity v2 and m1 moves with velocity v1. So the formula or the initial momentum of this system will be equal to m1 u1 plus m2 u2, and it should be equal to the final momentum, which is m1 v1 plus m2 v2. So this statement for the conservation of momentum should be remembered, that the total initial momentum is now equal to the total final momentum. Okay. So it explains us a various phenomena. A number of phenomena are explained on the basis of the conservation of momentum and the third law. Okay. Like if you have seen a fireman holding a hose pipe. Have you seen that fireman holding a hose pipe?
Yes.
Yes. So what happens?
Sir, the fireman gets pushed backwards because of the force from the water hose.
Yeah. See here, see here, as you can see here in this picture, the firemen they are holding a hose pipe, but you can see here we have four people who are employed who are there to hold the hose pipe. Okay. Why there are four people at as when the water is moving out of the hose pipe, so it provides for the conservation of momentum, there is a backward reaction, and hence the hose pipe itself should move in the backward direction. So due to the conservation of momentum, or the same thing can be explained even on the basis of the third law of motion, that when the when water comes out of the hose pipe, so a large force is required by the people to hold the hose pipe. Okay. Similarly, you can see a flying balloon. Uh, Suppose if you fill a balloon with air, and after filling out that balloon with air, if you release it, so balloon flies away in a direction opposite to the direction in which the air is moving out. Okay. So that is also for the conservation of momentum. We observe a recoiling of the gun. Okay. So while the recoil of the gun, if you observe, during the recoil of the gun, what happens? Your gun is pushed back. See, recoil of the gun. See. So what happens here? If you fire this gun in the here, if you fire the gun, see, so your bullet will move in the backward direction. If the bullet moves over here in the forward direction, so your gun will be pushed back in the down backward direction. So both will move opposite to each other so as to have the total momentum conserved. It cannot happen that the barrel will not move back. The barrel will move back because of the conservation of momentum. So you can be asked, why does a gun recoil? Yes.
Wait,
So
so
why?
can you explain it once more?
Okay. Let's see. Okay, so let's try to do this with this one. So here you can see in the initial stage, the total momentum of gun and bullet was 0. The bullet was stationary. The bullet was in the gun, which was in the stationary position. So therefore, in this situation, it was stationary, and the total momentum was 0. When the bullet was not fired, the total momentum was 0. And when the bullet is fired off, when the bullet is fired off from this gun, so this bullet, it gains energy and it moves in the forward direction. Okay. So bullet now has momentum in the positive direction. Therefore, to have the conservation of momentum, the gun must recoil back with, and it must have a backward momentum, which is negative momentum, so that still their sum can be 0.
Oh, sir. So like when you get slapped, like the person moves in a negative direction, so that cancels it out. Does it work like that?
Again, can you repeat your example?
Like suppose you get slapped, does law of conservation take into place then? Like the person who got slapped gets knocked back, so it goes in the negative direction, so it becomes 0 again.
So where he goes in the negative direction?
Left, right?
No, no.
Then how
See,
will it work then?
see over there, you have to look again for the conservation of momentum. Okay. But for the conservation of momentum, you have to understand the total system. First of all, if you understand your system, what is the system working over there? So see, suppose a child is slapped. So let us say this is the face of the child and he is being slapped. Okay. So if your child is being slapped like this, so now what happens actually from the hands, he is being slapped. So the hand has some momentum. Okay. So the hand has some momentum and his body or the head of the boy is at rest. This is at rest, but it has some momentum. Okay. Now the total momentum before it is not zero. If you find out the total momentum of the system, that is momentum of the slab plus the momentum of the head is not equal to zero. It is mu. It is not zero. The person who is slapping, he is not giving you slap with a zero velocity. He is striking your cheek with a certain velocity. So therefore, it has certain initial velocity, right? Now,
Yes.
when it touches your cheek, so over there, it we want to have the conservation of momentum. So his hand does not stop eventually. Your head will be pushed forward because of the momentum. Since he had a momentum in the positive direction, the slab had the momentum in the positive direction. So your head will also be moved in the positive direction. Got it?
So the energy is not conserved.
Where are moving to energy then? Yes, understand first the momentum concept. So have you understood about the momentum?
Yes, sir.
Okay. The similar thing can be explained while collisions occur. Okay. So while collisions occur, what happens if two cars collide? Okay. So that scene when the two cars collide, over there you have the conservation of momentum. Now we will solve some of the questions based on the conservation of momentum. Okay, just wait. I have some questions. Okay, anyone if finding any problem in any of the papers or in any of, okay, I told you to send one of the paper, but I could not. We'll sending it maybe today. After the class, I forget that. Force and laws of motion, this is which chapter? This is chapter number 12 or 13? Yeah, here we have some of the questions. This is, I think, gravitation. And after gravitation, you have force and laws of motion.
Sir, it's a blurry.
Yeah, you'll get
Okay,
it
now
clear.
it's
You'll get it clear. Okay, see this question number 2. Okay, so try solving this problem. Two persons managed to push a motor car of mass 1200 kilogram at a uniform velocity along a level road. The same motor car can be pushed by three persons to produce an acceleration of 0.2 meter per second square. With what force does each person push the motor car? So you have to tell the force with which each person pushes the car. Okay, so Orosmith will explain. Orosmith, can you explain this problem?
Yes, sir.
I don't want the solution. I want you to explain the situation. Can you? What do you get from the question?
So two people are pushing a car of mass 1200 kg
Okay.
with uniform velocity.
So what does it mean when they are pushing it with a uniform velocity? What information do you get when it says that the people are pushing the car with a uniform velocity? So what information we get from this?
So covering equal distances in equal interval time.
Covering equal distances in equal intervals of time. But what information does it give us about the force? What information does it give us about the force? If the car is moving with a constant velocity, so what should be the net force acting on it? Yes, Rishika, what should be the net force acting on it?
Sorry, I got
Okay, see, understand the
sir, I
answer
did
is
a F equals MA and I got 240 Newton.
no, I don't, that's what I said. I don't want the answer. I want you to explain this problem. Okay, when it says that two persons managed to push a motor car of mass 1200 kilogram at a uniform velocity along a level road. So when they are moving it with a uniform velocity, so can I say that the acceleration is zero? See, what does uniform velocity mean? Uniform velocity means the object covers equal distances in equal intervals of time. It means that the velocity does not change. And if the velocity does not change, so can I say that acceleration will be equal to zero?
Sir, I have a question, sir, but they already gave acceleration in the question.
Yeah, so they gave, you need to understand this. Why did they give this? And why three people are pushing, so you are using only for one people, right? They have asked your question, with what force does each person push the motor car? Okay, see here. So when two people are pushing the car, you have zero acceleration as it is moving with a uniform velocity. Now, in the question, when three people start pushing it, when three people push it, so then it has an acceleration of 0.2 meter per second. Are you getting now the differences? When two people were pushing, the acceleration was zero. You can say here that the net force on the car is zero. However, the car is moving, but still the net force on the car is zero because there are only, when two people are pushing, there is no acceleration. Got it? Got at least this much?
Yes, sir.
Okay. So that means I can say the force applied by the third person is the net force. That is the force which is causing the acceleration. When two people, they switch with two people. So when two people were pushing, you have acceleration zero, no net force. And when three people start pushing it, you have an acceleration of 0.2 meter per second square. So that means the force applied by this third person is equal to mass times acceleration, right?
Yes.
So, and there is only one person, third person was single person. So you have here the force will be equal to mass times acceleration. That's 1200 multiply 0.2, and that you get
240,
as
240
uh,
Newton.
240 Newton. Okay. So the force applied by each person is 240 Newton. That means, can you tell me what is the total force applied by the three people? What is the total force applied by all the three people? Yeah, Smith, what will be the total force applied by all the three people? Smith?
So 720.
Yeah, 720. As one person is applying a force of 240 Newton, then the three people, the all the forces applied on the car will be of the three people. That's 240 multiply 3. That's 720 Newton. Okay. Now, can you tell me what will be the force of friction that is acting on the car? What will be the force of friction acting on the car? Yes. What will be the force of friction acting on the car? See, when two people were applying the force on the car was not accelerating. Okay. So, Aman, can you tell me what will be the force of friction?
Yes, sir.
What will be the force of friction acting on the car?
Sir, the friction is not given in the question.
It's not given, but I am asking, what will be the, can you tell me the force of friction?
Um, Sir, how actually I don't know how to find that.
Yeah.
Sir, I don't know how to find the force of friction.
Okay. So see, the net force obtained on the car is only due to three people, right?
Yes, sir.
So when two people were applying the force, so then the acceleration was zero. It was moving with a constant velocity. So that means they were just applying their force to overcome friction. So we can say that the force applied by two people was the force of friction. That is 480 Newton will be the force of friction. Okay.
Yes, sir.
Uh, go through the questions, whatever we are discussing. Siddhisri, Siddhisri,
Yes, sir.
can you solve this question? Third question. All of you solve this question 3. A hammer of mass 500 gram, a hammer of mass 500 gram, moving at 50 meter per second, strikes a nail. The nail stops the hammer in a very short time of 0.01 second. What is the force of the nail on the hammer? So to find out the force, you have to find out first the acceleration. You first need to find out the acceleration, and if you find out the acceleration, then you can find out the force given by the formula force equals to mass into acceleration. Harini, did you get the answer for this?
No, sir.
Okay. Can you calculate acceleration?
So,
Okay. What is the initial velocity of the hammer?
initial velocity is 50 meters per second.
Okay. And what is the final velocity of the hammer?
Mm,
Sir, is the final answer minus 2500 Newton?
Hmm. Is it minus 2500 or minus? Okay. Oh, yeah. Final answer is 2500. Right. So first of all, you find your acceleration. Siddhisri,
yes, sir.
you're not concentrating. Can you find out the acceleration here? Siddhisri, I'm talking to you. Can you find out the acceleration?
Sir, I'm doing so one.
You are doing. No, okay, just tell me what is the initial velocity of the hammer? From the question, tell me the initial velocity of hammer. Yeah. Harini, did you get the answer finally?
Sir,
Did you get the final answer?
no.
No.
Sir, is the final answer 25 minus 25 25 negative 25000000.
Okay, let's see. So, Siddhisri, see, you have the initial velocity of the hammer as 50 meter per second. And since the hammer is finally stopped, so the final velocity of the hammer will be 0. The time it takes is 0.01 second for the hammer to stop. Now, can I find out the value of acceleration over here? As acceleration is v minus u over t, so it can be v is 0 minus u is 50 divided by 0.01. So it would be minus of 50, and if you remove the decimal, you get two other zeros on the numerator. So minus of 5000 meter per second square. Okay. So Aman, you have done everything correctly. Just one thing you have not done. Did you convert this gram to kilogram?
No, sir.
Then. So finally, you have to find the force. What will be the force? Aman and Harini, what will be the force?
M into A.
M into A. Siddhisri? Siddhisri,
Yes, sir.
so what will be the mass? Can you tell me the mass? I think you did not read the question. Siddhisri, did you read the question?
Sir, 500 grams.
500 gram. So shall I use it as 500 gram or shall I convert it to kilogram then? How
Sir,
many kilograms?
500 grams only.
Only 500 grams. No. we always have to use the SI system of units. So for that, we have to convert it to kilogram, and hence this 500 will be divided by 1000. So your answer will be 0.5 kilogram. Okay. So now you find out your force. Your force will be given by mass times acceleration. Mass is 0.5 multiply acceleration, which is minus 5000. So you get here 25 minus of 2500 Newton. So Prince, did you get this answer?
Yes, sir.
Okay. Chavan Kaushik, what about your answer?
It's the same, sir.
It's the same. Okay. And Rishika is not here. You see? Now start for question number 4. In the similar way, you have to go for question number 4, but do use the SI system of units. If you have your question number 4, you can start solving it now. Can you see it completely? A motorboat of mass 1200 kilogram is moving along a straight line with a uniform velocity of 90 km per hour. So its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. So calculate the acceleration and change of momentum. Also calculate the magnitude of force required. Okay. So I will first look for the answer with Siddhisri. So Siddhisri, have you read the question? First of all, read the question.
I read, sir.
Okay. So what is the mass given?
Sir, 1200 kgs.
1200 kilogram. So we will keep it in kilogram or convert it to gram.
Grams, sir.
We will convert it to gram. See, beta, remember the SI unit. The SI unit of mass is kilogram. Okay. So you will always keep this mass in kilogram. Mass is always measured in kilogram. Okay. So 1200
Okay, sir.
kilogram. No changes. Okay. Now, what is the initial velocity?
25 meters per second.
25 meters per second.
Yeah, 25 meter per second that we get by converting 90 kilometer per hour. Then second one is 18 kilometer per hour. That is the final velocity, which will be equal to 5 meter per second. Right? And the time here is 4 seconds.
Yes, sir.
So now I want you to people to find both the things. Find the acceleration, also find the change in momentum. You also find the change in momentum.
Sir,
So
acceleration is a minus 5 meter per second square.
acceleration is
Minus 5 meter per second square.
okay minus 5 meter per second square. That is correct. And what is the change in momentum?
1 second, sir, I'm doing it.
Okay. Okay. So did you get the change of momentum? Change of momentum will be final momentum minus initial momentum.
Sir, I got minus 24,000 as
Okay,
a change in moment.
Okay. And find out the force then.
Oh, sir, I put I have to add one more zero to that. Yeah, there.
Yeah. So every time you either forget 1 0 or you put 1 0 extra. Siddhisri, what about your answer? Can I see your notebook, Siddhisri?
Yes, sir.
Okay. So can you show your notebook? Just 1 minute. Okay, Siddhisri, you can show. Siddhisri, show your notebook. Okay. I think you have that background effect.
Sir, should I send in you WhatsApp?
Yeah, I just sent it in the WhatsApp, right? That will also.
Sir, is force minus 6,000 Newton.
Okay. Force will be change of momentum divided by time. That's minus 6,000. That's correct. Okay. See, you found out here that what are the things? You find here acceleration. So acceleration will be equals to minus of 5 meter per second square. You get the change of momentum. So change of momentum will be
Minus
24,000.
24.
It's minus 24,000 meter per second. Kilogram meter per second. Okay. Then you find force, which is given by change of momentum per unit time. So minus of 24,000 divided by time 4, you get minus of 6,000. Okay.
I did for force F equals ma. That also works, right, sir?
That is also correct. Okay. That's also correct. You found out acceleration. So you find out mass times acceleration. That will also be the same. Okay. So see. And okay, see this 18th question now. 18th question you will do as a homework part. Let me add to the PDF, and I think you people should do it in the homework. Just how much momentum will a dumbbell of mass 10 kilogram transfer to the floor if it falls to a height of 80 centimeter? Take its downward acceleration to be 10 meter per second square. Remember the SI units. Take the help of SI units and then do this. Okay. So bye everyone. Good night and see you in the next class.
Bye,
Thank
sir.
you.